How does thermal efficiency work in a car engine? Imagine your car engine as a busy kitchen where fuel is the ingredient, and the goal is to turn that ingredient into a delicious meal that powers your vehicle. The secret lies in how well the engine converts the fuel's energy into useful motion. That's what thermal efficiency is all about. It measures how much of the fuel's heat energy actually helps move your car forward. Think of it as a scorecard showing how effectively the engine uses the energy from burning fuel. When you fill up your tank, the fuel contains a lot of energy stored in chemical bonds. The engine burns this fuel inside cylinders, creating heat and expanding gases. These gases push pistons, which turn the engine's crankshaft, ultimately moving your car. But not all that heat turns into motion. Some of it escapes as waste heat through the exhaust and cooling system. The more heat that is lost, the lower the engine's thermal efficiency. The maximum possible efficiency is limited by the laws of thermodynamics. The second law states that no heat engine can convert all heat into work without losing some as waste heat. The theoretical limit for efficiency depends on the temperature difference between the hot gases inside the engine and the cooler surroundings. This is called the Carnot efficiency, and it sets the upper boundary. In real life, most car engines have efficiencies around 25 to 35%. That means only about a quarter to a third of the fuel's energy actually moves the car, while the rest is lost. Several factors influence this efficiency. For example, higher compression ratios, how much the engine compresses the fuel-air mixture before ignition, can boost efficiency. Modern engines use advanced designs to safely increase compression ratios, extracting more energy from each combustion. The temperature at which the fuel burns also matters. Higher combustion temperatures can improve efficiency but are limited by engine materials that might melt or crack under extreme heat. Mechanical losses like friction between moving parts and air resistance also reduce efficiency. Friction in pistons, valves, and other components wastes energy that could have been used to power your car. Heat losses through the engine walls, exhaust gases, and cooling systems also take away some of the energy. To understand how well an engine performs, engineers look at the ratio of useful work to the total heat energy from fuel. Improving thermal efficiency means making engines that use fuel more effectively, which can save money and reduce emissions. In the end, thermal efficiency shows us how much of the fuel's stored energy is actually used to move the vehicle. It's a fundamental concept in thermodynamics that helps us design better engines and make transportation more environmentally friendly.